Next, I'd like to, let me make sure we're on time. Real quick. Okay, 3 minutes to spare, but that's okay. So next, I'd like to invite Yukang Chen to the stage. He is going to speak about Efficiency Unleashed, key upgrades to the CKB transaction pool. Please put your hands together.
Hello, everyone. Today, I want to introduce some key upgrades to CKB transaction pool. So first of all, my name is Yukang Chen. I'm loving open source project. I joined CryptApp in 2023. Currently, I'm working in CKB core team and fab team. So as CKB is becoming more and more stable, we are trying to put some efforts to make the code is easy to maintain, and also we need to make sure CKB performs well for all scenarios. So first we have done a refactoring job for a transaction pool with multi-index map, and the second one is a new feature. It's called replace by fee. And the third one is a new design for the script verification. So first of all, what is a transaction pool? I guess a lot of you have some background on block system, but I think transaction pool is overlooked. There are not a lot of materials on the internet about this part. Transaction pool is a cache used to store all the transactions received from the node or from the network peers. It also, a transaction may also be resubmitted to a transaction pool where reorganization happened. So in essential, there are a lot of transactions stored in the pool. Some of them have some relationships like the parent and the children. There are two most important operations for transaction pool. The first one is packaging. It means how we decided to pack the transactions. We need to concern some factors like the fee, the weight, and the acceptance fee, acceptance weight. Another important operation is evacuation, because we want to limit the size of transaction pool, so we set the maximum size for this pool. So when there are too many transactions in the pool, we want to select some transactions to be removed from the pool. So this is the advocate key. This is a unique design for CKB transaction pool. We use a two-step confirmation. This is used to solve the pagination efficiency issues. When a transaction is first submitted to the pool, it will first in the pending status, then it will be transformed to gap and then to proposed status. So in the initial implementation of transaction pool, we have 3 different data structures for store the transactions. The first is a pending queue to store the transactions with pending and the gap status. The last one is a proposed pool. So as you can see, a transaction will be pushed to the first one, then pop from the first one pushed to the next one. This is how the old design works. There are some problems for the old implementation. The first one is it is not easy to implement a sorting strategy for evacuation. If you want to sort for all the transactions, you need to sort the first one, then the second one, then merge these two. So it's somehow complicated. And there's no third depth or parent-child relationships recorded in the pending queue, but it is very important for the replace by fee, let's say. There are also some duplicate code for the 3 different data structures. Some functions are hooked up to the push or hook up to the pop. So as so the code is somehow complex. So the solution is we use a data structure to reflect it. This is a Rust package called the multi-index map. In essential, there are some hash map or bitch map in multi-index map. So we can get by some specific property or iterate by the property. It is a perfect suit for us purpose. So we fact transaction pool with multi-index map. This is a pool map in the transaction pool, and the pool map will contain entrance. The entrance is a multi-index map. There is a property called status to indicate the current status of the transaction, and there are two sorting key for in the multi-index map. So we finished the refactoring. We get a clean code. There's no performance regression. And we implement a more accurate strategy for evacuating transactions. And at the same time, we also contribute some of our improvement over the transaction pool to the upstream. We add some new operation, and there's also some performance improvement. So the other project can benefit from our contribute. That's the great sense of open source. And after we finished the refactoring, we found we are ready for new features like the replace by fee, because you can easily to remove transactions from the pool currently. So this is the next topic that I want to introduce. It is called replace by fee. Why we need replace by fee? Before we have replace by fee, if you want to some existing transactions to be packed more quickly, you can only create a new transaction. The new transaction will consume some output from the old transactions. But the child pays a high fee. So because the algorithm in transaction pool, they are trying to find a blockchain, trying to find a transaction chain which has a high is the fee rate. So if the child pays a high fee, so the parent will have a much higher possibility to be packed in the next block. So that's called child pays for parent, but it cannot handle all scenario. So we need a strategy to increase the fee for the existing transaction in the pool, but actually we cannot modify the fee property already in the transaction pool. So we need to replace the old ones. So this is the conflict transactions. So in the left part of the diagram, transaction 1 will be replaced because transaction 2 consumes the same input. If we allow the two transactions to be submitted into transaction pool, there will be a double spending. So we need to remove transaction 1. And the left part is a more complex scenario. Transaction 1, transaction 2, and transaction 3 will be all removed because there are some conflicts with the new one. So this is our workflow for replace by fee. In the commit stage, we need to find all the conflict transactions with the new one. Then we will check replace by fee rules one by one. And if all the rules have passed, we will try to remove the old one. Then we will submit the new transactions. Somehow the workflow seems very simple, but it is not very complex because there may be some security risk introduced by replace by fee. So there are some replace by fee rules. I don't want to go to one by one. It is very complex. So replace by fee have released almost, I guess, 1 year. And it is enabled by default. I guess all the running node will support this feature. So the usage is very simple. If you want to if you want a transaction to be packed more quickly, you can just resubmit the old transaction with a half fee. There's a more detailed documentation on this part. You can check it out in this link. So the last topic I want to talk about is script verification. So what is script verification? When a new transaction is submitted, they will be verified. Verify will start up CKB VM to run all the script in the transaction. If any of them are failed, they will be rejected. If all of them are passed, they will submit to the transaction pool. So there's some challenge from the large cycle transactions. The verification may cost a lot of time, sometimes maybe 10 seconds or even 20 seconds. But we don't want to the verification to block other components of the CKB node. For example, if we want to process a new block, we want to suspend the CKB VM, and then we want to resume the CKB VM after we finish the processing block. But CKB VM didn't have a good support for the scenario of suspend and resume. We need to set a maximum cycles when we start up a CKB VM. So CKB VM will stop at the cycles we have specified. Then it will dump a snapshot. So if we want to resume the verification, we need to load the snapshot and start from the stopped cycles. That's how it works. So the code is somehow very buggy because we need to store the internal state from CKB VM. We need to store the old cycles. So this is the old design for transaction verification with large cycles. When a new transaction is submitted, we will try to first run the 10 million cycles at first. Then if the cycle exceeded, we will push the transaction to a chunk queue. And there will be a background job to try to pick a transaction from the queue and then try to another 10 million cycles. Then we will check whether there's any suspend signals. If we haven't finished in this 10 million cycles, it will be pushed to the chunk key again. So this is how it works. There are some issues for the old design. The performance is poor for a lot of large cycle transactions. That maybe happen. And the code is hard to maintain. So thanks for the CKB VM teams have put some efforts to design a new strategy for the pulse. It is signal burst. So when the pulse signal is received, the verify work will set a pulse flag for the CKB VM. So CKB VM will stop to cost the CPU resource. So the verify work we can transfer to the waiting status. So we are waiting the resume signal. So when the resume signal is coming, we will resume, clear the pause flag, then resume the CKB VM. So you can see the CKB VM is still in the memory. We don't need the snapshot. We don't need to store the cycles. So it is this enables us to design a new script verification. We still have a verify queue for store the pending transactions. There will be a verify manager. The verify manager will start up multiple works. All the works will be try to pick up a transaction from the queue, and then we will start up the CKB VM for the work. So when there suspend and resume signals come, it will be controlled by the verify manager. The verify manager will send the suspend signal to a verify worker. Yeah, that is a new workflow. So in practice, we also find some scenario we don't want too many cycles, too many transactions with larger cycles will block the normal transactions. You can imagine there will be a scenario that if there are a lot of transactions with larger cycles, all the workers will be busy to processing the large cycles. So if the normal transaction may be waiting more time, but actually we can handle normal transactions in a very short time. So there will be a worker which will only for normal transactions, or the other works will be pick transactions by time step. Yeah. We have done some benchmark testing. We can see there are a lot of performance improvement with multiple works. Yeah. That's all my concern. Thank you.